Have you ever thought about how the stars and everything we see when we look up at the sky were created? Well, it's all called the universe. It's everything that exists. All the stars, planets, galaxies, and matter in space. It is believed that the universe was created about 13.8 billion years ago in a huge explosion called the Big Bang. And what is that? An explosion that created everything we know. So my old sports, this is EdDevelop, where you will find the best scientific and similar curiosities. Subscribe and activate the notification bell to enrich your day every time we upload a new video. And consider our Patreon. Find the link below in the description. Now, it is time for the fun parts. Did you know that after the Big Bang, the universe began to expand and cool, allowing the first stars and galaxies to form? You may be wondering how stars are formed. Quite simply, they are born when clouds of gas and dust contract under the influence of gravity and can coalesce into galaxies, which are large cosmic structures containing billions of stars and planets. But how big is the universe? The universe is very large, spanning trillions of kilometers. Light travels at a speed of 299,792,458 meters per second, and it takes years to travel between the most distant objects in the universe. In addition, the universe is very old, with a history of more than 13.8 billion years. Incredible, isn't it? In addition to stars and galaxies, the universe contains a large amount of dark matter, an invisible substance that does not interact with light, but is thought to make up about 27% of the universe. There is also dark energy, a repulsive force that accelerates the expansion of the universe and is thought to make up about 68% of the universe. In short, the universe is everything that exists. It was formed about 13.8 billion years ago from the Big Bang, contains stars, galaxies, dark matter, and dark energy, is very large and old, and continues to expand at an accelerating rate. Now, do you understand a little more, old sport? My old sports, don't forget to subscribe to the channel for more content. Anyway, I'll answer your question in more detail. Let's get on with it. It is common to speak of astronomical distances in light years, which is the distance light travels in 1 year, about 9 billion million kilometers. The diameter of the Milky Way is 900 billion kilometers, and the distance to Andromeda is 22,500,000 billion kilometers. These distances are enormous, even though Andromeda is part of the local group of galaxies, which is our neighborhood. The universe is so large that we cannot see it in its entirety, because there are regions whose light has not yet had time to reach us during the 13.8 billion years of the universe's life. In short, an end to the universe has not yet been found. The universe we can see, the known universe, is a sphere whose radius marks the distance between the regions that emitted the radiation we observe as cosmic microwave background radiation and our planet. If the universe were static, this boundary, known as the particle horizon, would be 13.8 billion light years away. However, it is at a much greater distance of 46 billion light years, implying an expanding universe. To illustrate this result, the example of a sponge cake with nuts is often used. As the cake grows in the oven, all the walnuts see the rest of the walnuts moving away. When the cake doubles in size, two nuts that were 1 centimeter apart will be 2 centimeters apart, while those that were 3 centimeters apart will be 6 centimeters apart. In other words, in the same time, the distance between the most distant nuts will have increased 3 times as much as the distance between the closest nuts, which means they have moved away 3 times as fast. Now do you understand a little better? Have you ever imagined what space looks like beyond the Earth's orbit? Would it still be all black, or would there be other colors? Well, I can answer that by telling you that it is dark matter. Astronomers have calculated that dark matter makes up about 27% of the universe. It is called dark because it does not interact with light or any other form of electromagnetic radiation, so it cannot be directly seen or measured. Although we cannot see dark matter, we know it exists because its presence can be detected by its gravitational effect on visible matter. Astronomers have observed stars and galaxies moving faster than they should if they were only affected by the gravity of visible matter, suggesting that there is a significant amount of invisible matter exerting an additional gravitational force. This unseen force is thought to be caused by dark matter. Understanding dark matter is important because it may explain why galaxies and cosmic structures are the way they are. In addition, dark matter could have important implications for fundamental physics, as it could help explain unresolved questions in particle physics. Although dark matter cannot be directly seen or measured, its presence has been detected through its gravitational effect on visible matter. While its exact composition remains a mystery, its study is fundamental to understanding the structure and evolution of the universe, and could have important implications for fundamental physics. So, how does it differ from dark energy? Dark energy is a form of energy that astronomers estimate makes up about 68% of the universe. Unlike dark matter, which exerts an attractive gravitational force, dark energy appears to have a repulsive force, meaning that it accelerates the expansion of the universe. The existence of dark energy was first postulated in the 1990s, when astronomers observed that distant supernova appeared to be further away than they should be if they were only affected by the gravity of visible matter. Dark energy was found to be the most plausible explanation for this acceleration. Understanding dark energy is important because its presence could have significant implications for the fate of the universe. It is believed that if dark energy continues to accelerate the expansion of the universe, there will eventually be a point at which the expansion accelerates so much that galaxies will move away from each other at a speed faster than the speed of light, meaning they will never come into contact again. And yes, we are talking about a number of light years that not even the best astronomer will be able to decipher. This brings us to a very common question. How did all this happen? We've always been fascinated by the universe, haven't we? And while we can't know for sure how it all began, there are some fun and crazy theories worth exploring. The Big Bang Theory is probably the most popular. According to this theory, the universe began about 13.8 billion years ago as a singularity, an incredibly dense and hot mass. Then, in a moment called an explosion, the universe began to expand and cool, allowing the formation of the stars, galaxies, and planets we see today. But the Big Bang Theory is not the only explanation for the origin of the universe. The steady-state theory suggests that the universe did not have a beginning, but has always existed and will always exist. According to this theory, matter is constantly being created to compensate for the expansion of the universe, which means that the universe does not change over time. Another interesting theory is the multiverse theory, which suggests that there are multiple universes, each with its own physical laws and characteristics. According to this theory, our universe is just one of many, and the diversity of universes may explain why certain conditions and values of physical constants are necessary for life to exist in our universe. Of course, these are only some of the theories about the origin of the universe. Other theories include the cosmic inflation theory, which suggests that the universe underwent an extremely rapid exponential expansion shortly after the Big Bang, and the quantum creation theory, which suggests that the universe may have emerged from a quantum vacuum. In conclusion, it's fun to explore the different theories about the origin of the universe and everything in it, even if we can't be sure how it all began. From the Big Bang Theory to the multiverse, there are many fascinating explanations for how it all began. Let's keep exploring the universe. What's your favorite theory? Let us know in the comments. Thank you for making it to the end of this video. My old sports, don't forget to subscribe to the channel for more content. See you next time.